work. So hopefully this will be okay. I apologize for all the technical difficulties. I'm really working with people to make sure it happens. But I want to make sure everything is working the way it needs to be. Um, so we're starting on a new unit, module 3, and that's relations and functions. And it's really abstract. So hang in there if you're having a little bit of trouble with it. So remember, relation is a set of ordered pairs of x and y values. And we define the domain as the input or the x values of the function and the range as the output. And so what I wanted to show you is some examples of relations that were functions and some that are not, and how functions are shown to you. And then I'll go on to some domain and range. Okay, this is going to be a little bit lengthy, but hopefully you have all the notes that I emailed to you guys so that you can use these as a backup, and it'll help walk you through it so you don't have so much writing to do. So anyways, so here's one of the easiest ways that we are shown a relation is through a set of ordered pairs, where each one of these is an x and a y value, okay? So here, if you notice, the easiest way to tell whether or not a relation is a function is if you look at the ordered pairs and that the x values are not repeating. So remember, our domain, which is our x values right here, is 1, 3, 1, 3, 5, 7, and 9. And I list it like this. When I talk about my range, it's the output of the function. So remember, that's also our y values, which is here. It's 2, 4, 6, 8, and 10. Now, these are really basic examples. So hopefully you've got some more extensive ones in the exercises that you've gotten. Okay. Here, another example of a relation that is a function, which might be kind of strange to you, is that we have a bunch of x values that are different, but the y values are exactly the same. So when I mention the domain, it's all these input values, but my range is just one y value. So you don't repeat the y values or the x values when you're mentioning domain and range. You just you just list them one time. So you need to have as many or more domain values as you do in the range to determine whether or not it is a function. So let me give you an example of something that is not a function, because that's usually the biggest one. This is, again, ordered pairs are the easiest way to tell. Here, we have x values are 1, 3, and 1 again. So do you see how this 1 repeated? And so my input is 1 and 3, and my range is 2, 4, 5. Now, a big giveaway that this is not a function is there are more of a y values. There are more y values than x's. Okay, so your x values cannot repeat and they can't go to more than one y value. So that tells you that it is not a function. All right. Now, the next way that we can, a lot of times that we write down relations and functions is through a table. And I give you an example of one that is a function and one that is not a function. It's just a different way of writing x and y values. But what's kind of nice is when you put it in a table, the domain is on one side and your range is on the other. Here, if you notice, this one's not a function because my domain repeats here and here, okay? But again, here my domain would be 1, 3, 5, and 7, and my range is 2, 4, 6, and 8. Here, for my domain is 1 and 2, and my range is 2, 3, 4, and 5. Now, this is not a function, okay? This one is a function, okay? All right, so moving on, we'll talk about mapping. Now, mapping is kind of common when we're talking about relations and functions, but then we don't see it a ton more until we get into higher level math. So you'll see it with domain and range. You'll probably see it on your SOL, and I'll try to give you some examples, but just kind of hang in there, okay? So again, your domain is all usually on this left bubble and your range is on your right. And what happens is there's an arrow from this side to this side, and that's your ordered pair. So this one maps to 5, so I have the point 1, 5. 2 maps to 7, so I have the point 2, 7, and so on and so forth. 3 to 6, so 3, 6, and 4, 8. And if you notice, these do not repeat, and there's only one arrow leaving each one of these x values. Now, this one is an example of a relation that is not a function because I have more than one arrow leaving one number on the left, okay? So here 1 maps to 3, and then it also maps to 4. And then a lot of times if I have people having a hard time understanding whether or not it is a function or not, I said, well, let's just write out the points. We have 1, 3, 1, 4, and 2, 5. Well, our x values repeat, so it's not a function. So remember, guys, it can be it can be very just as straightforward as that. So try not to get too much in it. And again, like I said, very abstract, just hang in there. Okay? So another example, I always like to show this one because a lot of people get confused because your y values can repeat. And if I were to graph it, it would look like a horizontal line. So here your y values cannot repeat, can repeat. So this would be 1, 2, 2, 2, and 3, 2. This is a function, okay? Your y values can repeat because there's one arrow leaving each one of these points on the left side, okay? Now, another way to tell if something is or is not a function is when you have graphs, we use what's called the vertical line test. The vertical line test says that if you draw a vertical line through a graph at any point and you hit that graph more than one time, then it's not a function, okay? So here I gave you some examples of functions and things that are not functions. So as you can see right here, if I draw a line right through here, I hit this graph at 2 points or a circle. That is not a function. These are all functions. Any lines that are not vertical lines are functions. This is not a function because it's a vertical line. The x values repeat infinitely. Okay? So these are all examples of functions and non-functions. So make sure you hold on to that and use that as a reference. Okay? So when we get to naming domain and range of types of graphs, that's when it gets really abstract and kind of funky. So I want to make sure you guys understand this. When you're talking about, we can do this in set notation or with inequalities, and I'm going to do both, just so you guys understand. Some symbols that I want you guys to understand is when we talk about set builder notation, that's when we have an open circle, we use just a regular parenthesis. And when we have a closed circle, that's when we have greater than or equal to or less than or equal to. And that means it includes that point in the domain and range. And this is for continuous graphs, which means lines, parabolas, and stuff like that. So here's an example. All lines that go up or down, that have a positive or negative slope, have a function, have a domain of all real numbers and a range of all real numbers. Now, the domain, when we name it in set builder notation, it goes from negative infinity to positive infinity. Again, be patient with yourself when you're learning this. It just takes some time, okay? So that means it goes from the left to the right forever and ever. And because we can't define infinity, we use this kind of open circle concept, okay? Horizontal lines are also always functions. Their domain is always all real numbers, and your range is that one y value that's constant in every single one of these points. So I say, okay, pick a point. You have an x comma y. This is the range. So it's just that y value right here. Okay, and I'll get to some other examples too as we go. Vertical lines are not functions, but we can still talk about their domain and range, okay? A vertical line is not a function. Its domain has one x value because this x value is always the same for every point on here. The only thing that changes is the y values. So my domain is just that x value, whatever that x value is, And my range is all real numbers, or we can say from negative infinity to positive infinity. Okay? Now, parabolas are something that we'll get into later on this year, but this gives you an idea of what some of the graphs that we're going to be doing. Parabolas are like U-shaped graphs that usually point up or down. These are always functions, okay? Now, it depends on whether or not they're a minimum or a maximum. Minimum is when there's a bottom to it, and maximum is when there's a top. And that tells us what the domain and range is. Now, the domain for each one of these is always going to be all real numbers, okay? Because they go on to the left and right forever and ever and don't stop, okay? We just can't always write those points, but so our domain goes off to the left and right forever and ever. So my domain for both of these is all real numbers, which is also from negative infinity to positive infinity. Now, if it's pointing up, that means it has a minimum point and no maximum. So the y values are y is greater than or equal to whatever this minimum value is. The way that we would say this in set builder notation is it would start at this minimum value and go up to positive infinity. Okay, you might need to watch this a couple of times to understand it. So just hang in there again. And I'm going to go through some other guided examples. Here, your domain is all real numbers again, and your range is, because it's a maximum, it goes down. So it starts at this point and it goes down forever and ever. So it starts at, has a maximum of y, and it goes down to negative infinity. Okay? So these two are kind of similar. They're parabolas that point left and right. Now, neither one of these are functions, as you can see, because they don't pass that vertical line test, right? So my domain is going to be just like how I did my range up here. So it's going to go x is greater than or equal to whatever this x value is, or x is less than or equal to. So if it's going this way, it's less than or equal to, okay? And if you have a hard time understanding this set builder notation, just concentrate on the less than or equal to and greater than or equal to first, and we'll get to that later, okay? The range is what goes on forever and ever because it keeps going down forever and ever, and these arrows are a big indicator of that. Okay. The other thing that I wanted to show you were absolute value functions, and those are almost identical to parabolas because they have the same kind of thing where they have a minimum or a maximum and they point up or down or left or right. So it's really the same exact thing. So remember, those are, again, have a domain of all real numbers if they're pointing up or down. And then the range depends on whether or not there's a minimum or maximum, okay? So one of the things I like to do is when I teach my classes about domain and range of graphs, because it's usually the most abstract concept and it's very difficult, is that I go and say, okay, you need to go back to your generic graphs. These are like parent graphs that we use, and these are some of the ones that I mentioned and that I've drawn right here, so you can kind of get an idea of what to expect from them. Okay, so again, when you're going left or right, your range is what's going to be all real numbers, and your domain is going to be x is greater than or y is less than, or x is greater than or equal to, or x is less than or equal to, depending on which way it goes. So remember, if you look at the coordinate plane, your domain is your your range is your y value. Okay, and your domain is your x values. So it gets greater as it goes this direction. So it's either greater than or equal to. If it's heading in this direction, it goes in less than or equal to, depending on whether or not that point is included. And then your range is, again, your y value. So if it goes up, it's greater than or equal to, and down is less than or equal to, okay? And that always depends on whether or not that point is included. 99% of the time, the point's going to be included, okay? So That's what I want you guys to realize. And if it's going in both directions, that's a key to tell you. If it's going in both directions like this, it's all real numbers. If it's going in both directions like this, it's all real numbers for your range. And this is your domain. Okay, so be careful with that. So another example of a function that you guys might see, probably not in Algebra 1 as much, but in Algebra 2, this is a cubic function, all right? This is x cubed. This also has a domain and range of all real numbers. The reason why is if you see it's going this way and up. So first let's talk about the horizontal behavior. It's going to the right and it's going to the left forever and ever. So that tells me domain of all real numbers. And then it's going up and down forever and ever. So it has a range of all real numbers. I know that sometimes it can be confusing because it looks like it's just pointing up. But remember, if it keeps going this way, no matter what the rate, it's still all real numbers. So be very careful of that. Okay? Now, some other examples of functions that you guys are going to see, not a lot, but one is the square root function, and that's y is equal to the square root of x. Now remember, square root has to be a positive number. You can't take the square root of a negative number, at least not in Algebra 1. It's not on the real number line. So this would start at, normally it starts at 0 and it goes this way. All right, okay. So here, wherever this starting point, now this can be transformed left or right, just like lines can. So wherever the starting point is, remember it's going up, so it's greater than, it's going to the right, so it's greater than or equal to, and it's going up, so y is greater than or equal to. Now it can be transformed going in the other direction, so just be careful of that. So again, I'll give you some other examples that I'll take you guys through. All right, some other examples that would not use the greater than or equal to or less than or equal to is they would use, because they're starting at an open circle, so it does not include that point, but it's all those points greater than. So here's an example of domain and range where they would be less than, and remember, because this is still going up, even if it's going to the left, the y values are still greater than here. So if up and down is what you need to think about for y values, and left and right is for x values. Okay. Now, the other one I wanted to include, because my students we've touched on it before, is something like a sine function. And you guys don't see this until you get into trig and everything, but it has a maximum and a minimum value, okay? So my y values max out at +1 and lower out at -1. So that gives you an idea of where you have bounds for upper and lower bounds here. Okay, so again, these are just some basic samples. I want you to hold on to these because these kind of walk you through some of your basic functions, and you can use those to help you with a lot of them. I've got some other stuff that I want to go over with you guys today, if I can get my live lessons working, and I'll let you know. So hopefully this is a good introduction of what we've done. Please send me some specific questions and stuff that you want me to work through. Again, remember that you guys are all relatively close to me at Colgan, so if you wanted to get some extra help, you are all more than welcome to come see me at Colgan after school. I'm usually there almost every day after school, so, or I can meet you all at the library or something, whatever's easiest for you. But hopefully this will help you guys. Let me know if you have any other questions. I'm still working on the live lesson stuff, so hopefully that'll work out, and I'll talk to you guys soon. Bye.